Okay, so what we are doing is a practice questions task style question for Math 3052. You guys don't have to pay attention if you don't want to, but you can. It's the secondary 3 statistics, and this is a probability style question. It is not a perfect question. I'm going to admit that right now. I don't really like it that much. It was a big pain to create this question, and you can tell by all my erase marks what a pain it was. Because I wanted to set up this scenario so that this fraction could be part of the question. But when you just make up all the numbers at random, you end up with, you can't turn it into a fraction. You end up with a horrible decimal that goes on forever. So playing around with the numbers allowed me eventually to get this 2/10. I'm going to read the question just to get started. So the bridge normally has heavy traffic in the afternoon. You get out of school between 3:30 and 4:30. At 4:04, 2 extra lanes open and the traffic becomes very light on the bridge. That's great. But at some point after that, a nearby factory ends its day shift and the traffic becomes horrible, not just heavy, horrible, which lasts for 20% of your hour. 20%. So what's happening here in this first half of the question? The information is only partially given. You can figure out how many minutes the bridge has heavy traffic, but then you have to use this 20% to start figuring out the others, and you need to. Now the extra lanes are opening only 4 minutes earlier because they've made a change in the highway schedule, so now things have changed. And a timetable change at your school means you're getting out of school between 3:24 and 4:29 instead. Your chance of hitting light traffic is now 2 out of 10. How many minutes each of heavy, light, and horrible traffic do you now face, and what are their percentages? This is a horrible, horrible question that's asking for a whole bunch of things. What are we going to do to answer it? The approaches are, the student who wants to just figure it out is able to get a sprinkling of marks, a few marks. They'll get full marks if they can explain everything, if they can justify everything they figured out, but most students can't do that. They're really weak, so they just write down answers and they don't explain where they got them, and the mark's going to be bad. So I'm not recommending that strategy. Another approach is to apply the math that you've been learning from this course. Now, if you're ready for the exam, you look at this and you're trying to think, what type of math are they asking for? I'm hoping that the idea of favorable over total is popping into your heads, because that is what I'm going to use when I'm answering it. This is a really good strategy for a student who is not able to figure out an answer and explain everything perfectly. Because you have practiced with favorable over total if you're getting ready for this exam, so you know how to do that, and you just get started doing it. I am going to get started doing it. And it looks like I don't need very much information, but that's an illusion. You actually need quite a lot. It's going to be difficult to fit it all into this space. First thing I'm going to do is, even though it might seem really obvious and the student might not want to do it, it's like saying 430 minus 330 equals 1 hour or 60 minutes. Okay, that's really messy. And I'm taking up too much space for such a simple little calculation. Okay, now we're looking at the information that's given. Now, we're doing this twice. We're doing it before they made the change and after they made the change. So yeah, 1 hour, they're very obvious. The heavy traffic is lasting until 4:04. So the student needs to say 4:04 minus 330 is equal to 34 minutes. Very useful number. But how do I put that as favorable over total? I'm just going to put 34/60. Okay, now we're starting to talk like students who've been doing a probability course. 34/60 is going to give the probability of hitting heavy traffic before they made the change. And I may as well convert it into percentage right away. I'm not going to show all the little steps of that because I'm going to run out of space on the chalkboard. But 34/60 is 56.7%. and you are going to catch me if I make no mistakes and say something so I can fix it, because I'm videotaping this and I don't want it to have mistakes. But yeah, 34 minutes makes sense. Okay, so the next thing we have to do is that 20% of your hour. Now, a lot of students are just going to quit right at this point because, oh no, 20% of an hour. 20% of anything is easy, and all students know that. It's the fact that it's an hour is what's going to make people choke. Time is happening in this question, and I'm making it happen on purpose because time can happen in any of the questions on the exams. And it's not just going to be the number of minutes in an hour. There's also the number of seconds in a minute, which is also 60. Number of hours in a day is 24. Days in a week is 7. Oh, it wouldn't be so nice if you could use really simple numbers like the 24 and the 7. But the 60 bothers a lot of people. And then there's months. That's a lot of fun. Making up questions that involve months and the days in a month. Can you open the door and let the student in? The days in a month keeps changing. You have 30 and 31 most of the time, and then you have 28 or 29 when it's February. This is a big pain. So even if I make a question that starts in April and ends in October so that I can avoid February, the student still has to deal with some months having 30 days and some have 31, and that really, it throws a lot of complications in. And it's enough to make students choke and want to just quit on the question. But this is an exam question, or we're pretending it is, so you can't allow yourself to choke. So all that just to say 20% times 60 minutes is equal to 12 minutes. It's not actually hard, and it is something that people can do in their heads. But, of course, don't. Okay, 20%, 0.2 times 60. I have it right? I'm going to let you be my my verifier. Okay, so we have 12 minutes, which means we have 12 over 60, which of course is 20%. So the percentage was kind of given here. I'll write it anyway. 20% of the hour is going to be, where did it say that? Horrible. That's horrible. I really need to label these. So I'm putting HE for heavy and HO for horrible. Oh no, I'm using HO as an abbreviation. Oh well, how unfortunate. Okay, so now we have to get the other one, which is the light, which actually is what matters the most, I think, to the student who's leaving school and is trying to calculate these probabilities. I want to try and make it so that I hit the light traffic. Okay, so there's two ways of doing that, of course. We can subtract with the fractions, and that's going to be 60 minus, these are the numerators, not the numerators, 60 minus 34 minus 12 equals 14. So it means it's going to be 14 minutes. Again, you have to write that down. It's obvious, it's really fast to do in your head or in a calculator, but if you don't write it down, you're going to lose marks on an exam question. So we can say the light, Li, is 14 out of 60. We can also just do the complementary, right? Because that is complementary, what I just did. The total is 60, so if I subtract the other ones, I figure it out. But I can do that with the percentage. The total of these two percentages is 76.7%, so 22.3% is going to be the percentage I get right now. So let's verify that. 14 divided by 60, is it 22.3? 23.3, I screwed it up. Okay, 23.3%. So we have all the values we need to talk about anything before the change. Now we have to do after the change, and this is where I think a lot of students are going to choke. It's worse than the fact that you have to deal with 60 minutes for that type of student who lets things like that make them choke. Because after, we have two changes that have happened, which is that the extra lane opens 4 minutes earlier. That's good. When you get there a little earlier, you hit the light traffic. But the school, the time that the student is going to get out of school has changed also to 3:24. That's a bit of a pain. So the 4 minutes earlier means it's 4 o'clock. That's actually a nice clean one. Minus 3:24, that's 36 minutes, right? Yes, it makes sense. So that means we have 36 minutes for the heavy traffic. I'm going to put that HE label again. We're going heavy first again. But our problem is that the denominator has changed. Because when you calculate this, 324, 429, I have to show that. 429 minus 324, it's now 65 minutes. That really is going to bother a lot of students. Because if they went this far and they were able to deal with the 60, then they're saying 60 makes sense because it's a number of minutes in an hour. Of course, that makes perfect sense to me. I'm really used to it. And now suddenly I'm dealing with 65 minutes. It's like my hour is 65 minutes long now. So that's going to make people panic and freak out and want to leave things blank, but don't. So we have 36 over 65. Because the final question asked not only for how many minutes, which we just found, it's right here, but it asked for the percentage. Well, that's why I'm asking for the percentage, because I don't want this to be too easy. I'm trying to do a task style question, not one of those little questions. So 36 divided by 65 gives a percentage of 55.4. So we can see that the percentage has changed. It has gone down a little bit. The heavy traffic, there's a little bit less of it. Now we finally have to deal with this thing here, 2/10. What is 2/10 of 60 minutes would have been easy. It's not 60 anymore. It's 65. Ugh. So 2/10 times 65, 0.2 times 65, happens to be 13 minutes. That ended up not being so bad. And that's why it was so bad for me yesterday when I created this question and I kept on erasing the times and putting different times on, because I wanted to get something like that. I didn't want to get 12.9837254 minutes. I didn't want students to have to deal with that, because exam questions, they do try to avoid horrible decimals, because they want the student to be able to focus on whether they're proving they understood something that was taught in the course. And this course isn't really a horrible decimal course, is it? You're just supposed to already be really good with horrible decimals because of lower levels that you've done. So this is and that is the light. Chance of hitting light traffic. So I'm doing them in a different order now, just because of the order in which the information came in the question. Finally, it's not finally, I have to put 13 over 65 and get a percentage. No, I don't. It's 20%. It's 0.2. Oh, that's interesting. I didn't try to do that on purpose. So it's 20%. The light traffic is 20%. Oh, and yeah, it's just a coincidence, because in the first half it was the horrible traffic that was 20%. Wow. Okay, so now we can use complementary again if we want. We have to do the horrible traffic for the after the change. So it's going to be 55.4 plus 20 is 75.4, so 24.6. Hopefully I didn't screw it up this time. I'm going to do the minutes though. We have 65 minus 36 minus, this was 13. I can't really fit it. 65 minus 36 minus 15. 14. So we have 14 minutes, and 14 minutes is not out of, did I have that somewhere? Yeah, it's not out of 60 though. We have to put it over 65. So we're nearly finished, because the 36, 14, and 13 are the minutes that were asked in the final question, but 14 over 65 is the last of the percentages that we're asking. 21.5%. Does that make sense? 55, 75. Why is it not adding up to 100%? I may have to scrap this whole video.
Did you round down?
Yeah, I didn't think I made enough rounding to make this matter. 55.4 plus 20 plus 21.5 is 96.9%. I am really not liking this. I'm not happy at all. So I may scrap this video. I'm not putting it up on YouTube if it has some embarrassing mistake in it. But I'm still going to finish, because there's a point to the video, and the point to the video is the whole point of this lesson. If you get a question like this on an exam, what do? Do you just say, oh, that looks horrible, I don't want to answer it, and leave it blank? I have met students who do that, and I don't want anyone to do that. If you're going to do that, don't book the exam. Don't do the exam yet. What I'm doing is I am forcing myself to do a lot of favorable over total, because I know this is a probability question. So even if I'm bad at explaining things, I'm still able to get a lot of marks, because an awful lot of these calculations are necessary. If I'm just going to pretend I made that mistake on purpose, even if it is a mistake, the 96.7 thing. I'm a student. Students don't do exam questions perfectly. The students who do exams questions perfectly don't really need this video. Those students just walk into the exam and get 100. So what is it like to be a real student, the much more common student who doesn't get hundreds on exams? These things happen. You're reading this horrible, confusing thing. There's a lot of reading comprehension involved. You're doing your best to do all sorts of calculations because you know the course wanted you to do these style of calculations. You kind of have a feeling, like I do right now, that something went wrong and you're not really sure what, but you still want to get as high a mark as possible. Well, the person who gives this answer is going to get as high a mark as possible, but I don't think they're going to get full marks because everything that was asked for was answered. There are units of measure, minutes mainly, and it didn't really ask you to sort of judge something at the end, like a task question sometimes does. I'm going to stop recording soon because the part 2 of this question is actually, the part 2 of this video is actually another question, which isn't quite as long. But the point is to be able to look at 2 questions that look really different and realize that they're actually supposed to be the same question, the same type of question. Because that's what happens with exams. They have multiple versions of exams. They want to ask the same questions on every exam, but it would be silly to ask the same questions, so they make up other questions that are kind of similar. And I want students to go into the exam room, and it really doesn't matter which version of the exam they get. So you want to be able to recognize a type of question for what it is. A student who thinks this is statistics should not be writing the exam. This is a probability question. So that's a little bit of a leap right from the beginning. I'm going to pause now, and I'll record again soon. Okay, part 2 of this video is another question. It doesn't look like the same question, but it's meant to be the same type of question. In April, I gave my kid an apple on 12 of the days. I gave them a banana on a third of the days and a pear on the rest. Not that confusing. In June, I gave 5/4 as many apples, and every student's thinking, 5/4? Are you serious? Why are you saying 5/4? Why are you throwing fractions at me? Because that's what happens in this course, that fractions and percentages happen. 5/4 as many apples as in April, and the number of bananas represented 1/6 of the days. So we have a bunch of fractions in here. How many days did I give a pear? And what is the change in probability? So the part after the comma, what is the change in probability, is important because otherwise you could answer this whole question without using probability style math at all. And I want to kind of force the students to use it so that they practice using it. The difficulty of creating practice questions is that I do not want to devote as much time creating a question like this as I would if I was hired by the government to create real exam questions. I can spend a whole day making a beautiful exam question, I suppose, but I need to make so many of these so that people can practice that I do not want to spend a whole day making a good question. I want to make a good question in a minute, improvising it if I can. The lower the level of math, the easier it is to do that. But you get to certain types of math where if you make up questions just having fun with it, you end up creating questions that are confusing the student more than they're helping the student. So this one actually is not very confusing. One of the things that's bad about this, if you wish, is it's too easy compared to the real exam questions. This paragraph, it was actually typed on an exam, would be 2.5 lines long maybe. And task questions on exams are definitely longer than that. And reading comprehension is one of the things that they are testing you on, even though as a math teacher, I think that that belongs in the English exam. But no one's listening to me. So the students are tested on reading comprehension, whether we math teachers like it or not. This one's kind of easy to read. What else is different between this and the heavy traffic, light traffic question? There's a couple of very big differences. And one of those differences is we're now days in a month. If we're going to do favorable over total, we have to do days in the month. But notice which months I use, April and June. So with the bridge traffic question, we started with an hour and then it changed to 65 minutes. And that was one of the things that created difficulty. But in this one, we're starting with April, which is 30 days, and then it changes to June, which is also 30 days. Didn't change it this time. Why? Because exam questions that you could be practicing for might do something where they change it, like the bridge traffic question, but they might also do something like this where they don't change it. And I want students to be able to handle either way. So I have to do that. And it worked. Okay, I'm going to start answering it, and then we'll analyze it a little bit more. I may not even have to sit down at first for this. Okay, so 12 days in April. This is going to be apple, so I'm putting an A. 12 days out of 30. This is a rather easy one. although the percentages are going to have decimals in them. 12 divided by 30, we have 40%. 40% chance in April of a kid getting an apple if you want to express it with favorable over total. A banana is on a third of the days. 1/3 times 30. That's kind of an easy one. So it's 10 days. And then 10 divided by 30 is 33.3%. Also easy. I'm going to say AP for April here and just sort of block off a section of the chalkboard for this, because I'm going to do June afterwards. So then we have pair. Pair is the rest. Well, this is too easy. It's too easy to do in your head. So when I say too easy, I don't mean it the same way that people usually mean that. It's too easy because when you can do things in your head, you forget to write them down. And in an exam, you have to write it down because I have to play dumb. So 12 plus 10 is 22, 30 minus 22 is 8. I did that in my head. I know that the pair is going to be 8 out of 30, but if I'm correcting the exam and the student does this, I'm saying 8? What 8? I don't see an 8. Where'd you get an 8? So teachers have to pretend to be really dumb when we correct exams. So how did we get the 8? We need to show it. 30 minus 12 minus 10 equals 8. There. I have now justified where I got the 8. 8 over 30. And again, we can use complementary, either with the, well, we did it with the fractions. We can do it with the percentages as well. 40 plus 33.3 is 73.3, so 26.7 is going to be the percentage I'm going to get. 26.7%. And then I double check. 8 divided by 30. Yep. And I double check because I don't want to ruin this video, but I also double check because the student should. I'm really pleased with you if you're really smart about doing calculations in your head, but in an exam, double check. Okay, so we have all the information for April. We need to do the information for June. It's still over 30. This feels too easy. In June, I gave 5/4 as many apples. Okay, so maybe it doesn't feel that too easy. 5/4 times the number of apples in April, so 5/4 times 12. I know that's 15, but a lot of students would really need to do the calculation. But again, if you don't need to do the calculation like me, then you're tempted to just write a 15 here. And then you haven't justified it. So 5/4 times 12 is 15, has justified it. And 15 over 30 is a nice easy 50%. That is, I'm going to put JU, and then I'm going to put an A for the apple. Now we need banana and pear. Bananas is 1/6 of the days. 1/6 times 30 is also an easy one. That's 5 days. And then 5 divided by 30 is 1/6. So if you know what 1/6 is in a percentage in your head, it means you're either a math teacher or really lucky, but it is going to be 16.7%. Double checking, 5 divided by 30. Yep, the show off is right, it's 16.7%. And then the pair, we can do complementary. 15 plus 5 is 20, 30 minus 20 is 10. I have to show that. 30 minus 15 minus 5 equals 20. And then, 30 minus 15 minus 5 equals 10. And then 10 over 30 is 1/3, so it's 33.3%. Whoa, 33.3%. Pair. Hey, no, again, it's a coincidence. I got 33.3% both times, but one of them it was banana and the other one it was pear. So we have, I think, finished answering the whole question. No, we haven't. The change in probability. So that's why I put it there. Because otherwise, you could answer this with all of the numbers of pears, numbers of apples. You never would really have to do the favorable over total thing at all. You wouldn't be doing very much probability and you get away with it. But the change in probability forces us to recognize this is a probability question and we have to do some probability if we want the marks. So the change in probability is the change in pair probability, which is 33.3 minus 26.7. Did I do that part? It is going to be 6.7, isn't it? Yep. So the change in probability is now given and the question is now complete. This seems way too easy to be a task question. But whenever you completely understand one of these task questions, you always think it's too easy. So that happens to the teachers when we see the task question but we don't know the answer yet. And then we look at the answer key and it's like, oh, I can't believe it's so short. Students often have a really whole big page of answer for that and you're wondering whether they're right or not and you're all confused. And you see the answer key, because the person who made the answer key knows the question inside out, they completely understand it, so they're able to be quite brief. But a student who is really ready for the exam and who understands the course very well will have the same experience. They'll be sitting there in the exam room, having done this, and saying to themselves, I can't believe that's all I needed to do. For such a big question worth so many marks, how come it took so little time? But we have covered everything. I think I've answered everything. The thing, I guess, the last thing to say before I stop recording is it's really the same question. This is really the same question as the light traffic, heavy traffic question. It really doesn't seem that they're the same on the surface, but they're testing the same stuff. They're testing whether the student can do a bunch of little things. So we look at stuff we had to do here and we compare it to that other one and we realize, yeah, we had to do that as well. Putting pre-verbal over total again and again, applying the concept of complementary as part of the process of doing that. We had to do that in both questions. Having to do it all twice was another thing that happened in both questions. So this can definitely happen in a real exam question.